Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and very good afternoon. My name is Muhammad Razali bin Shamsuddin and today I would like to present my work, the title Insight into Chemical Properties and Surface Morphology of ENR PVC Filled Cellulose Grafted PMMA Membrane. Okay, membrane consists of active layer which is very selective and support layer for the flux. The selective particle pass through the membrane is called permeate, but the particle cannot pass through it called rejection. Membrane are used extensively in variety of industry including water purification, petrochemical refining, pharmaceutical manufacture, mining, building, and space exploration. A composite membrane with several advantages has been created by combining ENR and PVC. This composite hybrid structure of plastic and rubber make it possible to generate a freestanding single membrane that doesn't require support material. The treating with water with high oil content can be less successful when using ENR PVC composite alone. Methyl methacrylate MMA can be grafted onto cellulose to enhance membrane performance in water oil filtration. Alteration boosts the membrane hydrophobicity and creates sufficient porosity of effective water and oil separation. So, for this study, the objective is to develop an effective ENR PVC cellulose grafted PMMA membrane and to understand the chemical and morphological properties of the membrane and to determine how functional group affect bond breaking and formation of new bond. And lastly, to identify the relationship between surface morphology and pore formation. For the method, there are several steps of method to prepare the ENR PVC cellulose grafted PMMA. First, preparation of cellulose from pineapple leaf and modification using grafting polymerization. Next, preparation of ENR PVC cellulose grafting PMMA membrane using phase inversion method. And then, chemical analysis using FTIR spectroscopy to identify the functional group. Next, the textural properties of analysis using FISAM to determine surface morphology and porosity. And then next we will take a look on filler preparation. The filler preparation were prepared from pineapple leaf. The pineapple leaf were cut and dry, followed by ground to get a fine pineapple leaf fiber. Preparation of alpha cellulose involve the main three steps. First, it's including alkali treatment, bleaching, and filtration. As previous documented, the tapping method was used to extract cellulose from pineapple leaf. The following protocol previously described in the literature with the extracted cellulose is functionalized with PMMA by graft copolymerization. The fabrication of the thin film. The thin film manufacturing process consists of two main stages. First, matrix preparation and thin film molding. The ENR PVC is prepared using solution mixing process. Epoxidized natural rubber is dissolved in tetrahydrofuran to produce a homogeneous solution. 6 grams of ENR is soaked overnight in 80 ml of THF agitated until homogeneous, then mixture with 4 grams of powdered polyvinyl chloride. The ratio of ENR to PVC is 60-40, whereas the ratio of the matrix to THF solvent is 1:8. The phase reversal of solution molding are used to generate ENR PVC cellulose PMMA thin film. 10% of grafted cellulose PMMA filler were introduced into a homogeneous ENR PVC matrix solution during the solution molding process to examine their effect on the thin film properties. To make sure the filler are dispersed equally, the mixture is stirred After that, the solution is poured into the glass surface and smoothed with a 0.035 mm thick casting knife. Reversing is a liquid phase into solid state is known as a phase reversal to remove THF solvent and enable the creation of ENR PVC cellulose grafted PMMA film. The level solution is rapidly evaporated and then immersed in the distilled water before being removed from the glass plate and allowed to dry at the room temperature until sufficient mature for additional analysis. The membrane is allowed to finish phase reversal about 10 minutes. Then the characterization was take place. In the characterization, there are two main analyses were carried out. Next, we go through for the discussion. See the peak at 3,300 to 3,400 per centimeter refer to the vibrational stretching of the hydroxyl group OH and hydrogen bond that exists between cellulose molecule as well as water absorption peaks, and peaks around 1,650 to 1,630 per centimeter to stretching of OH group from the cellulose. Next, the peaks around 1,736 per centimeter refer to the stretching vibration of ester carbonyl C double bond O. And COC bonds peak at range 1,058 per centimeter and 1,030 centimeter cube. Next, the formation of aldehyde HC double bond O functional group was detected by stretching vibration of CH bonding at 2,776 per centimeter. Next, we go through for the beyond grafting of cellulose grafted PMMA. In the initiation step, the cerium ion can exist in form of Ce4+, Ce3+, and Ce6+, depending on concentration of nitric acids. The hydroxyl group at C6 and the glycol C2, C3 location are the main location where free radical originate. The diol group oxidize 6 times faster at glycol C2 to C3 than is that at the hydroxyl C6. So, the reaction will occur at C2 or C3. And then, C4 plus cellulose coordination complex is formed because of this C4 plus ion attacking the hydroxyl group on the C2 and C3 carbon of cellulose. C4 plus ion are used in the oxidation process of different alcohol and substrate with hydroxyl group when perchlorate and nitric acid are present. We can see that the C4 plus cellulose complex that reduced to the C3 ion, which causes the free radical to be produced at the C2 or C3 location of the glucan repeat unit. This starts the propagation steps. And then we can see the formation of decreasing intensity of OH functional group from FTIR of PMMA compared to the cellulose show the formation of C4 plus cellulose coordination complex with attack on the OH functional group mainly at C2 and C3 position. The formation of an aldehyde functional group HC double bond O during the breaking bond of the C2 to C3 position. And then we go to the propagation step. In the propagation step, the free radical react with the vinyl monomer that are in the reaction mixture. This free radical target the double bond in the methyl methacrylate monomer, leading the formation of new bond. The free radical also transfer occur within the methyl methacrylate change, resulting the formation of polymethyl methacrylate. And for the proof, the formation of peak at 1,736 per centimeter refer to the stretching vibration of ester carbonyl C double bond O bond belonging to PMMA that grafted onto cellulose backbone. The intensity of COC bond increased at range 1,000 and 58 per centimeter and 1030 per centimeter by Pmma bone grafted on cellulose. And lastly, the termination step occurred and the free radical attack continued the polymerization of the change. The change termination is achieved when free radicals interact with each other, producing a natural polymer. We go through for the membrane FTIR. So we can hear the peak at 2090 and 2800 per centimeter belong to CH2, and then 1450 per centimeter peak is corresponding to the CH bonding of the thin film, and then the asymmetric and symmetric stretching vibration of the CO peaks at 1254 per centimeter and between 1110 to 1000 per centimeter. And then the epoxy ring COC peaks is absorption peak at 876 per centimeter. And lastly, the CCl bond by absorption of peak at 699 per centimeter. Then we go through for the surface morphology. First, we see the cellulose show the smooth surface fiber as obtained with the fiber diameter of around 4.5 nanometer. 4.5 micrometer. The cell grafted PMMA show the rough surface with a flaky texture, increasing the diameter of the fiber around 10 micrometer due to grafting PMMA coated to the top of the fiber surface. And then ENR PVC membrane show a smooth face, stable and uniform morphology. No observable pore formation either on the surface or cross section. And lastly, for ENR PVC cellulose grafted PMMA, the formation of fine pore with a more texture appearance. Although the membrane surface becoming irregular, the view does not the transcoolant pore in the sample. And then we go to the pore formation. From the FISEM micrograph, we can see that the cross-sectional reveal the formation of pore between the filler and the membrane as well as between individual filler particles. And then the pore formation in ENR PVC cellulose grafted PMMA can be attributed to the three principal mechanisms. First, solvent evaporation and substitution. In the post-drying, the residual water vaporized, resulting in the formation of fine pore, and then the substitution of the part of the solvent by water and non-solvent lead to the pore creation. And then next, the filler metric interfacial. The pore interaction create gaps between the filler and the matrix, which manifests as function pore within the thin film. The filler-filler interaction increased concentration cause the particle to aggregate, leading to the formation of filler pores. And then lastly, we go through for the conclusion. At all things considered, it can be concluded that the FTIR spectroscopy proved the successful grafting of PMMA by C double bond O, H C double bond O, and CH bonding. Next, grafting PMMA into cellulose resulted in a rough, flaky surface roughness and increase in the fiber diameter from about 4.5 micrometer to 10 micrometer. Pores were found within and between filler particle as well as between the filler and the membrane. Improved pore development within the membrane was largely caused by interaction at the interface between filler and the membrane and the filter. I think that's all for today. Thank you.